In this problem, we're trying to determine what this m is going to be, where we have informally proven that the limit as x approaches 4 of x cubed minus 4x squared plus x equals 4. Let epsilon be greater than 0 be arbitrary. Choose a delta that's the minimum of epsilon over m, comma 1. And so we're going to find out what m is going to be. Now, in doing this problem, the fact they gave us the 1 as one of the options, we're going to use that in just a little bit when we go to plug something in. So what we have, a couple things I want to point out is, first of all, remember it's going to be x minus a is greater than 0 and less than delta. And the absolute value of f of x minus L is less than epsilon. So let's put some information into this. We have 0 is less than x minus 4, because our a is 4, is less than delta. And we're going to build up this delta in such a way that we can then determine what would be the two delta choices. They gave us the one is the 1, and the other one is epsilon over m, and we're going to figure out what that would be if we plugged a number in. Okay, so I keep saying this, but this other part's not so necessary right now. I take it back. We do need to do this part. X cubed minus 4x squared plus x minus, and the limit there is 4. Needs to be less than epsilon. So if I work on this a little bit over here, I have this x cubed minus 4x squared plus x minus 4. It's not an epsilon, you're thinking. You just wrote the same thing again. Well, I'm going to factor this by grouping. It's 4 terms, and they luckily group quite well together. So I will have the absolute value of x squared times x minus 4 plus 1 times x minus 4 less than epsilon. So we have the absolute value of x minus 4 times x squared plus 1 less than epsilon. And we could write that as the absolute value of x minus 4 times the absolute value of x squared plus 1 is less than epsilon. Okay, so with that in mind, we see already, right now, we see this x minus 4 connection going on. And the idea is we want to then modify the x minus 4 to get it to look like the x squared plus 1. So we could use some fun-filled algebra techniques. And so let's go back and think of this as absolute value of x minus 4 is less than delta. And we could break out the absolute value to be negative delta is less than x minus 4 less than delta. And again, the goal is to make this say x squared plus 1. So I'm going to add 4 to all the parts. So we'd have negative delta plus 4 is less than x less than delta plus 4. And one thing that's true is we can make an upper bound bigger, and we can make a lower bound smaller. So we can do these two things, but we can't make an upper bound smaller or a lower bound bigger. And the idea is we want to have, I want to say, kind of mirror opposites on either side of this. And right now we don't have that. So I could do this, say, negative delta minus 4 is less than x, less than delta plus 4. I essentially made the lower limit smaller by basically subtracting 8 from it. And then that's definitely, if something's 8 less, it's going to be smaller than what it was. So the inequality would still hold. And this allows us to then say, okay, the negative of delta minus 4 is less than x, less than, that's a plus, delta plus 4. Now remember, our goal is to have that x in the middle become an x squared plus 1. So if I were to, let me rewrite this as the absolute value of x is less than delta plus 4. I think that holds pretty well. And then if I were to square both sides, I'd have the delta plus 4 quantity squared. And then if I were to add 1 to both sides, I have absolute value of x squared plus 1 is less than delta squared, delta plus 4 squared plus 1. And what I want to point out here is now that this expression here looks a lot like that. And so what the process is talking about in this problem is they said, okay, and they arbitrarily chose. They said that, okay, delta, oh, wrong one. They said that delta is going to be the minimum of epsilon over some number m, comma 1. Well, they gave us that 1. We can take this 1 now and plug this back in to this delta and come up with 1 plus 4 squared plus 1. That's 5 squared plus 1. That's 26. And so, meaning that our epsilon over 26 would be the other option. Because what we're seeing here is that in forming this, we're trying to build it up to be the epsilon. If the x squared plus 1 part, let me rewrite what I have up there down below. I'm going to go back to blue. The absolute value of x minus 4 times the absolute value of x squared plus 1. The idea is if we were to call this x squared plus 1 epsilon over, well, no. If that was considered to be 26, then our delta, which this part is referenced to be more like the delta, would need to be epsilon over 26, so that epsilon over 26 times 26 would divide out and result in just the epsilon. And that's what it's about. And that's why, for this problem up here, it would be that m would have to be 26. So delta is the minimum of epsilon over 26, or 1. So that is your m. I hope that helps.